Hello and welcome to the C programming lecture on function pointers. So let's go ahead and give a brief overview of pointers and functions. These are topics that we've already covered in other lectures, so if you're a little fuzzy on them, just go back and revisit those other lectures. So a pointer is a variable type that value is a memory address. Pretty simple. A function is a block of code that can be invoked with parameters. So if we just purely think about our code as data and operations that we can perform on this data, we can think of that the function actually has a memory address associated with it. So thinking about it in this manner means that we can actually create a pointer to a particular function. So this is a pretty crazy concept when you think about it. So a invocable piece of code actually has a memory address associated with it. That memory address can actually be assigned to a variable. So here's an example of a function's address. So what we have here is in line 3, we create an increment function. That increment function returns a int and also takes one parameter, which is a x int value. So that particular function we can see on line 7, we print the address of the actual increment function. So that would be the actual implementation, which is line 12. So combining pointers and functions. Again, we have the ability, since there is an address associated with the function, to say that we can point to a particular function because it's just a memory address. So in C, again, we can declare a type that is actually a pointer to a function signature. So what that looks like in the abstract is over and to the left, we have a particular return type with the function name and a pointer star at the front with the parameter list. Now in practice, what this may look like is to the right. Let's say that we have a math function, just like we had before, our increment function. And what we can do is we can have an increment with a pointer here, and then it matches the actual signature of that particular function. So here is an example of using our prior increment function with a function pointer. So what we're doing here on line 7 is we're declaring a function pointer, which is the name function pointer. This particular variable is actually a function pointer that points to the actual implementation of the function increment. So we can actually invoke this function pointer just like we would a regular function by passing in the value 4, and we can see that it returns another result, and that return result should be 5, which we do see that in the output. Now, if we had a decrement operator, we could actually swap these out, and it would be fairly intuitive as to what's going on, and we reuse that same function pointer variable rather than using specifically the increment and decrement function names. So some practicality is used when having to do sorting operations or comparison operations. Typically you will pass in some type of sort or compare function for that particular thing to run. So the C standard library, typically things like quicksort would have you pass in a function pointer to evaluate comparisons. So here is an example of function pointers with a typedef. So what we are doing here is we're creating a typedef. That particular typedef is actually a type, an alias now. And what we can do is we can declare this function signature here as a variable f, and then we can assign that now to our increment. So it's basically working the same way as before, except we have this nice neat alias here, which is defined on line 5 here. So definitely write down this code and mess around with it and just get more familiar with how this particular function pointer syntax works. It looks a little weird at first, but you'll get used to it. Now again, let's have a brief review. Functions are not variables, but they are stored at a particular memory address. So every function actually has a memory address, although they are not variables. Function addresses can be stored within a variable defined as a function pointer. So that's a very interesting point to make. is to say that you can actually have a variable that is a function pointer that can be invoked as well. So that's just another detail that you should familiarize yourself with. So a typedef can be created in order to lessen the verbosity of the function pointer. So basically just an alias, just like our other typedef syntax that we use for enum structs and unions. So let's go ahead and jump into some code here, and let's just mess around with some of these function pointers. Okay, let's go ahead and jump into an example of using function pointers. So let's go ahead and create our basic boilerplate code here. Again, we just do this as a way to check our tooling to make sure everything is working as expected. So we can just go ahead and write this real quick. Yep, okay, everything's working, great. So let's go ahead and start out by declaring some functions here, and we're just going to go ahead and do them at the top to change things up. So we're going to have an increment and perhaps a decrement. So we're going to return x plus 1, and again here it's a decrement, so we're going to change the name to de decrement. There we go. And now what we're going to do is define a type def that is going to be a function pointer to a particular math function, let's say, that has the signature, it returns an int, and also takes an int as a parameter, which is exactly these two particular functions, what they do. So x is equal to 0, we'll say. We're going to go ahead and print x out here, x. And now what we'll do is we're going to go ahead and say, okay, we have a math func. Let's call it f, and that's going to be equal to increment. And now what we can do is say x is equal to f and reprint x. So far, let's just make sure we're compiling and working as expected, and everything seems fine. Great. So what we're going to do is we're going to copy these last two lines, copy this line as well, and we're going to change this to decrement. So our output that's expected is going to be 0, 1, 0. Right. So what we're going to do is erase that part because we don't need to redeclare it. And that's exactly what we get. So again, this is basically, you can think of a way to just swap out functions of a particular case. So what you could do, and what often happens, is you'll have a function that actually takes in a math function. So you can have something that's like int do, math operation, and that particular math operation, maybe it takes in a type of math func. If you define this down here, maybe it takes in a math func, and then in that it just invokes it, right? So you have a math func f. So maybe this function does exactly that, right? So it's going to return the result of the math func like so, and then this particular thing you have to also include a x in to pass into the math func. So the same results can actually be achieved by doing the same exact thing. It's a little weird to do it this way, but if for instance we wanted to do it that way for some particular reason, we could basically do math operation. That's going to return us the same results basically. So if we wanted to increment, we would just say, okay, let's just use different values here. We'll pass in the increment function and the address of the increment function, and let's just say 100. I want you to increment this by, so we should receive 101 back, assuming that this actually returns what we expect. Okay, so this is actually f. There we go. And that's exactly what we expect. So again, typically you'll see we can do the exact same thing here. We can just leave it at, let's say instead of 100, let's do 1000. And we're gonna pass decrement. So again, it's just another way to be able to pass function pointers and have functions do explicit things on them for some particular reason. So again, it's as a convenient way of us to pass functions to either other functions or to use them as variables. It's a pretty powerful way of handling stuff, and you'll often see them in sorting functions or traversal functions or something along those lines. Anyways, I hope this kind of gave you a good example of how to use function pointers and how they work. Definitely copy this down and step through it and make sure that you understand it pretty well.